Hello and welcome to another video. In this video we're going to be continuing on with the TypeScript line 75 and we're going to be doing missing number. So in this problem you're given an array nums containing n distinct numbers in the range 0 to n and you want to return the only number in the range that isn't missing, or that is missing. So you have an array here and it's going to be in the range 0 to the length of the array, right? So this is going to be 0 to 3 and we need to figure out what's missing. So here 2 is missing, so we want to return 2. Here, our range is 0 to 2, right? 0 to the length of the array, and 2 is missing, so we return 2. And here we have 2, 4, 6, 8, 9 numbers, so we have 0 to 9, and we are missing 8. Okay, so essentially, you have some array of some length, and you want to figure out what number is missing 0 to length, right? And there has to be a missing number because you can't fit all of these. Because if an array has length, it can only fit 0 to length minus 1. But we are trying to figure out what's missing in this range. So there's a few ways to do this one. And kind of the way I did this originally was, let's say you just take like 301, for example. One thing you could do is you could like modify your numbers somehow. So what you could do is, let's actually walk through this bigger one for this example. So we have 9, 6, 4, 2, 3, 5, 7, 0, 1. And let's actually write out the indices just to make it easier. So we have index 0, 1, 2, 3, 4, 5, 6, 7, 8. So one thing you could do is you could go to every number and then you could take that number and then whatever it points to, like mark it in some way as it's there, right? And so, what I mean is go to the number. So for 9, we're gonna go to the index that this number is going to. So 9 is out of bounds, so we can't do anything here. But let's say for this one, we're just gonna go one by one and do this. So this goes to index 6. So we're gonna go to index 6, and we can essentially just add some huge number, right? Like if this constraint is 10 to the 4th, we can add like 10 to the 5th or 10 to the 6th or something. Right. So the way I'm going to represent that is I'm just going to add like a 6 or something, and that means we're going to add 10 to the 6th, essentially. So we're going to go over here. We're going to go to index 6, add 10 to the 6th. Okay. Then we are going to go to index 4, add 10 to the 6th. And then we are going to go to index 2 and add 10 to the 6th. Then like here, once you're at this number, you're like, well, do I go to index 10 to the 6 plus 3? No, because the easiest way to do that is every number you go to, you can just mod by 10 to the 6 to get the original input, right? So if you go to this number and your number is like 10 to the 6 plus 3 and you want to get the 3, you can just mod it. Like every number you go to, just mod by 10 to the 6th before then to get the original number. So now you would go to 3 and add a 10 to the 6th. And then you would go to index 5, so this is itself, add 10 to the 6th, go to index 7, add 10 to the 6th, and then go to index 1, add 10 to the 6th. Then you're going to have to do one more pass. I think I might have missed one, did I? Let's see here. Did one of these go to 0? Yeah, this went to 0, so this 10 to the 6th. Yeah, there we go, okay. So now you can see like you're going to have two cases. Either one of these numbers won't have a 10 to the 6th, or if the actual number that's representing the length is missing, then you're just going to go through and you're going to say, okay, this is all fine. So then I have to be missing the length number, right? So in our example here, 8 is the only one that doesn't have this 10 to the 6th because nothing points to 8. So we're going to go through our numbers again, and we're going to say, okay, any number that doesn't have 10 to the 6th added to it, that's going to be our missing number. And if this is all fine, like let's say this did have a 10 to the 6th, that means that all of these numbers, 0 through 8, are actually here, and then the number that's missing is the 9, right? So if this was an 8 instead, actually get rid of this. So if this was an 8, then this would have a 10 and 6, then you'd go through it all and you'd be like, okay, fine, then we know that 9. So that's one way you could do this problem, is with just like going to every single index and giving it some kind of either adding a number or adding a character, or, just changing it in some way where you could recognize like, hey, this has been visited. Or a visited set, I guess, whatever you want. But there's two cooler ways that I wanted to show on how to do this. So for one thing, you should know, or at least you can know is, we will break it down into a smaller problem here. If you have a bunch of numbers, like let's say you just have a bunch of numbers, right? And we're going to kind of like see how this relates. And I think we did this problem earlier, and they are all, there's 2 of every number except for 1. So we just have like 1, 1, 2, 2, and the order doesn't matter here. Like this works anyway, so we can even throw in like something like this. We can throw in 8 here. So there's 2 of every number, and then there's 1 single number. There's 2 ways to get the single number. One is, well, actually, in this case, there's only one way really, because it's hard to know like if we've seen it before without using like a storage. But let's say we had these in 2 different arrays, right? So let's say we have 2 arrays, and one has all of one number, right? So let's say it has like 1, 2, 3, 4, and then the other one has the same thing, except one of these arrays also has an extra number, and you know which one it is, right? Like let's say you know this top one always has an extra number, for example. Let's just say it has a 5, right? So all these numbers are duplicated except this top array has one number that the other one doesn't. So, and this can be in any order, it doesn't really matter. So one way to get everything, and this will work this will work if all the numbers are in the same array as well, is you XOR every single number. So you XOR all of these and all of these. And essentially what happens is if you XOR them all, I'm not going to go through like XORing bit by bit, but essentially if you XOR a bunch of numbers and all of them are a pair and there's a single number, you're going to get this single number at the end. So you start with 0, and then you XOR every single one of these. You will get 5 here. Now, a more intuitive solution, but this one is a little bit worse because if your numbers are big, it gets expensive, you know, worst case scenario, is you can just add every number up here, and then you can subtract every number down here, and you're just going to get the difference, right? So we're going to get like 1 plus 1, or 1 plus 2, plus 5, plus 3, plus 4. And then you subtract all of this, so minus whatever this is, 1, plus 2, plus 3, plus 4. Right? So that's the other way you could do it. Either XORing, and that'll keep your results small, or you can add, but like I said, let's say like, for example, you had 10 to the 8 numbers or something, and all your numbers were like really big. Like all your numbers could be like 1 from 10 to the, or from 1 to 10 to the 9th or something. You wouldn't want to like keep adding, you know, a bunch of those because you're going to get like a really, really big number. So adding does have this memory concern, but does actually work. So let's figure out how we can do this with either adding or XORing, right? And our problem, the constraint is small enough to where either one is fine. But like I said, XORing is still preferable. But how do we go from that to this? So essentially what we can do is we know that we are looking, like for example for here, we know we're looking for numbers 0 to 9, right? And there's 1 missing. So what we can do is we can just XOR, right? We can just XOR, we can start at 0, and we can XOR 0 with 0 to 9, and then we can XOR it with all of these. And we know one of these is missing, essentially. You obviously don't need to XOR with 0, I guess, because anything, well, yeah, I think anything XOR'd with a 0 stays the same, I want to say. I could be wrong about that, but I'm pretty sure I'm right. So I guess you can skip the 0, but either way, we can do it as well. So you take your number, you XOR it with everything 0 to 9, and then you XOR it with all of these. And then essentially here, you're going to also have 0 to 9, but you'll have one number missing, right? And then that's going to be kind of the same case, right? So imagine we have lengths from 0 to 9, and then these numbers are also 0 to 9, but you have one number missing. So essentially, there will be one number up here that's not in the bottom, and it's kind of the same thing, where every number will be repeating except for the duplicate. So you could do this XOR solution, or you could do this add solution as well, where you add 0 to 9, and then you subtract all of these numbers down here, so you will add 0 to 9, and then you subtract everything, and what's going to happen here is that the top part will have 8 more than the bottom part, right, if you add them all, because the bottom part is missing an 8, and then you'll get an 8. So either one of those works, and that's pretty much like the solution without modifying any of the input, is either add the top and add all this blue and subtract the green, or XOR everything completely, and that would also work. So we're going to go with the XOR solution just so I could show it, but adding also fine because our constraints are small enough. But like I said, typically it would be worse because you're making your number bigger and bigger and bigger. So what we're going to do is we're actually going to go through like the range of all our numbers, right? We're going to go from 0 to length minus 1. So we're going to actually initialize a number to nums.length. And the reason for that is because, as you can see, like we're going to go through, add all the indices and all the values, but we're going to initialize our value to this because we're traversing through the array. This is never going to be in here. This is going to be like too big. So we're going to initialize it to this and then XOR with all of this and all of this. And I think that's kind of like a cool solution, so let's do that. So we're going to say number is nums.length. Then we're just going to loop through all our numbers. So for I equals 0, I is less than nums.length, f is plus. We are going to XOR our number. And so you can actually do an XOR equals, which is like num equals num XOR something. So we're going to do num XOR I, and then we're also going to do num XOR the actual value, right? So we're taking every index and every value, and we're XORing everything. And then this is going to be nums I. So now our number should be the missing number because everything's a duplicate except for 1. So now we can actually return it. And let's see what happens. And I think we should be good. Yeah, so as you can see, it's pretty efficient. We're not using any space. We're not modifying anything, and XORing is more efficient than adding because, like I said, if these do get big, it's going to be a problem. These are only 10 to the 4th, so if you add a bunch of numbers 10 to the 4th, I think to fail, you need to have like 10 to the 9th or something. Actually, technically, it's not going to fail anyway because additions, like your number can get bigger than 10 to the 9th. But keep in mind, I do think that like once your numbers get big enough, I think adding is no longer O of 1, I want to say. Like as your numbers get big enough, additions take longer. So just a slight memory thing there. Okay. And so let's go over the time. So essentially we're looping through every single number, so that's going to be O of n. And for the space, you're just using constant space, right? We're just having a constant number and that's it. So yeah, it's going to be all for this one. Not too bad, kind of a cool solution here. And hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.